All right, so let's take a look at reviewing your constant acceleration motion model. So we're going to start with looking at some of our different quantities and symbols. So first of all, position is our location relative to some origin, and we usually use an X for that. If we're talking about vertical motion, we will use Y as well. If you just want to stick with X, that is perfectly fine. And we're typically going to use meters. Okay, we can use centimeters, we can use millimeters, we can use kilometers. Meters is kind of our standby. Okay, and initial position is our starting location. We're still going to use whatever letter we used here for position, in this case X, but we're going to use a little subscript 0 on it, and that reads as X naught, or you could just say initial position. And that just tells us where we're starting from. We're also going to use meters. Whatever units we use for position, we have to use the same for initial position. Then displacement is the change in position. So change in, we use the Greek letter delta, which is just a little triangle. And so we'll say delta X. Okay, so remember, displacement is just change in position. Where did we end up compared to where did we start? And displacement is a vector, okay, because direction is a part of that. So for displacement, we'd have to indicate, is our displacement to the north, south, east, west, up, down, left, right, etc. Time, we're just going to use a lowercase letter t, and this is going to be in seconds. And time is a scalar. Time doesn't have direction. No such thing as time up, down, left, right, backward, forward. We can't go back in time. So at least for now, time is still a scalar. All right, so let's talk about velocity. So typically for velocity, we're just going to use a letter V. And I put instantaneous here in the parentheses. That just means like, what is our velocity at this moment in time? Okay, as opposed to an average velocity or anything like that. Our units here are going to be meters per second. And velocity is a vector. There is direction associated with it. Okay, so velocity to the right versus the left will be different. Our initial velocity, kind of like with initial position, we just use V with a subscript 0 that reads as V naught, or initial position. And this is also in meters per second, and this is also a vector. So it's still a velocity, and it's still an instantaneous velocity. This is just our velocity when t was equal to 0 seconds. Okay, so that's kind of the definition of instantaneous velocity. I'm sorry, of initial velocity. What was the velocity at the exact moment when we set time equal to 0? Okay, and then acceleration, we just use a lowercase letter a, and this is our change in velocity per unit time. How quickly are we changing our velocity? And so that is change in velocity would be meters per second. And then this is per unit time, so that would be per second again. So you can write meters per second, or meters per second squared. Either way, and this is also a vector. Okay, because since it's change in the velocity, and velocity has direction as well. So our acceleration could be positive or negative, depending on our change in velocity. And then the last one on here is our acceleration due to gravity. So this is just a very special kind of acceleration. We can still use the lowercase letter a, but sometimes we will use a lowercase letter g to represent that this is our special acceleration due to gravity. Okay, and in our free fall lab, we determined that near the surface of the Earth, this acceleration is negative 9.8 meters per second squared. So negative, because we're going, the acceleration is pointing down to the surface of the Earth. We can also approximate this to about negative 10 if we don't want to be super precise, if we just kind of want to get a rough idea. And just like regular acceleration, the units are in meters per second squared. And just like regular acceleration, it's still an acceleration, so it is still going to be a vector. Okay, so that gives you an idea and an overview of the main symbols and quantities that we are looking at when we study constant acceleration.